So this is going to be the Algebra 2 review for 2018-2019. Primarily the graphing techniques will be used in my classes. If you want to see some of the graph by transformations from previous years, you can look at the 16-17 video, the 17-18 video. That's on my YouTube page, but this will be for this year. Okay? So what I'm going to have here is I start with my anchor point. Okay? So since I have no parentheses, I can assume that that's going to be a 0 on the inside. I follow that sign. So whatever is here will be here for y. So 0, 1, 2, 3. Okay, remember this is the x coordinate and this is the y coordinate. Okay? All right. Then what I'm going to do is I'm going to go to my calculator and I'm going to graph it. Okay? All right, I'm going to graph x. X is right here, squared. Okay, minus 3. Execute, draw. Okay? That gives me my idea of my picture. Now, I want to go to GSolve and I want to find some of these things. So I'm going to use these 4 things. I'm going to go to root. Okay? It crosses at about negative 1.7, okay, which is like right here. And if I hit over, it crosses at 1.7. So negative 1.7 and 1.7. Okay? All right. Then GSolve max. All right, don't have one. Then you hit exit and draw to redraw it. GSolve minimum. 0, negative 3, I've already graphed that. GSolve y-intercept, I've already graphed that. So I've graphed all those. All right, I make a similar shape through the points. Okay? All right. Now we'll go to number 3 because I got to scroll down. The anchor point for this will be 1 because it's opposite of what is inside for x. Okay? There's nothing on the outside, so that will be 0. That 3 stretches the graph. So I'm going to graph 1, 0. Okay? All right. I'm going to go back into the calculator. 3, shift, square root, x, minus 1. I'm going to draw it. Okay, and I see that's my picture. Okay, so GSolve root, okay, 1, 0, I already have it. GSolve max, doesn't have one, so I have to redraw it. GSolve min, doesn't have it. GSolve y-intercept, doesn't have it. Okay, so that's my picture. Pretty simple. I just go ahead and draw my shape. Okay, it's a little ray there. All right, moving on to number 2. Okay, my anchor point now will be negative 1, 0, because it's the opposite of the inside, nothing on the outside. Okay, all right, this is an absolute value problem. So when I go into the calculator to graph this, what I'm going to do is I'm going to go into option, then I'm going to select num, which is F5, then abs, which is F1. Okay? Now, inside the function, I have x plus 1. Now, what I have to do is I use the arrow, I go outside the function, and I can put this fraction. The fraction is the ABC button. Whoops. I might have to type that in first. Okay, hold on. We got to type that one in first. Hold on. We got to put fraction. So ABC 1/5. Then I'll have over here then option num abs, and then I'll put x plus 1. So you have to put the fraction in first. Okay, and you can see this is like a V shape. Okay. All right. GSolve root negative 1, 0. I don't think I have any other ones. Always got to check for multiple ones. GSolve max, no max. GSolve minimum, still that 1. Okay, I checked for them, only got 1. GSolve y-intercept, 0.2, so it'll be about right here. Okay, and so the absolute value is a V shape. So I'm going to make a V shape. Okay, my anchor point here is going to be -4, because it's opposite of the inside for x, followed for y. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Okay? And then I'm just going to go into my graph. All right, when you want to delete something, all right, you do F2, all right, then delete it. Okay? So then I go Option, None, Apps. Okay, X plus 4 on the inside. Minus 7 on the outside. Okay, so I got my V shape here. Okay, now, since this is zoomed out a little bit, I need to learn how to zoom out. So I'm going to zoom out and then execute, just so I can see a little bit more. Okay, so G solve root. One of them is negative 11. Now, if I look at my graph, that's 1, 2, 3, 4, 5, 6, 7, 8. I go 9, 10, 11, just so I can have the dot on there. Okay, and if I hit over, the other one's at 3, 0, 1, 2, 3. Okay, G solve max, don't have one, exit draw. G solve min, that's my negative 4, negative 7, which I can confirm there. G solve y intercept, 0, negative 3, so 1, 2, 3. A good rule of thumb as you're looking at this calculator, this little flashing X sort of shows you where that point is. So you shouldn't really make any mistakes as far as, you know, where those are. And then I look at my shape is a V. I go through those points. Okay, question number 5. My anchor point, I got nothing on the inside. That's going to be 0. On the outside will be negative 4. Okay, so 1, 2, 3, 4. I want to have an idea of what it looks like. Now what this negative is going to do is going to flip the graph. It's called a reflection. Okay, all right. And we'll go back and write the transformation things in a second. I forgot to do that. All right. So what I want to do is I want to go in and delete these. Okay. All right. I'm going to do negative square root x. Outside I got a minus 4. Okay. G solve root. I have no root. All right. G solve max. I have no max. G solve minimum. I have no minimum. All right. G solve y intercept. 0, negative 4 is already graphed. So what I have here is a ray. So it goes like this. Okay. All right. This anchor point will be negative 4 for the inside, 0 for the outside. 4. Okay. All right. And what that 2 is going to do is just going to stretch it out, make it a little bit longer. Okay, so what I got is I got G solve root, got negative 4, 0, already got that. G solve max, don't have one. G solve min, negative 4, 0, I don't have any other ones. G solve y intercept, 0, 32. So we're not going to graph that. So we got to look at our shape. It's a quadratic, so it's going to be a U shape. So we're just going to go ahead and do something like this. Okay. All right, now let's talk about the transformations here real quick, okay? So what this was the way you would write this is a shift 3 down. That's all you did there. This one was a shift, okay, 1 right. All right, and it's got a dilation of 3. So if there's a number bigger than 1 there, that has the dilation, okay? All right. This would have a shift left of 1, okay? And this has a dilation of 1/5, okay? Okay, this has a shift 4 left and 7 down. So basically you're describing how the anchor point's being divided. So this is actually pretty easy. Okay, this is a shift 4 down. And I don't talk about the x because it's a 0. All All right, and because there's a negative here, there's a reflection. Okay, this is a shift 4 left. And this has a dilation of 2. Okay, so if there's a number out front, okay, that's the dilation. Okay, all right. You can see other videos for this. I'm going to skip through that. Okay, I'm just going to go down to here. Okay, this is a line. It's called a linear. This is our square root. This is absolute value. This is quadratic. Okay? All right? That's pretty easy. I think you guys know how to do that. Okay? I think I got one more. We got some more pages here. Okay. So the big thing you got to know in this is which one is going to be which. Okay? This first one, since it's a V, we know that it is going to be absolute value. Okay, and I'm just going to write out the absolute value. I'm going to leave something in front, and I'm going to leave this over here. Okay, then what I'm going to do next is I'm going to look at this anchor point. My anchor point is 0, -2. So what that means is nothing on the inside minus 2 on the outside. Now, this number out front is the only thing that ends up being tricky. Okay, when you do transformations, usually what you have in a transformation or a parent function is a 1-to-1, one right, one up. So what we do to figure out the number out front is from this anchor point, we go 1 to the right and we count up till we hit the actual, I'm going to draw this in red so you guys can get the idea. So I want to count over 1 right and I want to figure out how much it is to get to the red line. 1 right, 1, 2 would put me on the red line. So that's why that number is a 2. Okay? If you go down, if the thing were to go down, let's say you were, just as another example, let's say you went 1 right and you went 1, 2, 3 down. Okay, let's say the graph looks something like this. Okay? Then you would put a -3 out in front of the function. Okay? That's something you should know. Now this is a square root function. Okay? Now I got 1, 2, 3, 4. That's -4, 0. So this would be x plus 4 on the inside, nothing on the outside. Now, if I go 1 to the right from my anchor, it only is a 1 up. So you could put a 1 there, or you could just leave it. Okay? Moving on. Okay? State the x-intercepts and the y-intercepts. Okay? First one has been graphed for you. So the zeros are the same things as roots, and actually x-intercepts are the same thing, all right, and solutions. Those words all are the same thing, and that's very important to understand, okay, in Algebra 1. Let me move or Algebra 2. Let me move this over, sorry, the thing you can't really see. All right, so the big thing to know is zeros, roots, x-intercepts, solutions, all right, are all the same thing. And the way you find those in a graph is where it crosses the x-axis. So it crosses at x equals -1 and -3. So you can write the same thing for x-intercepts for the same answer. The y-intercept is where it crosses on the y-axis, which would be right here, 1, 2, 3, and you write that as a y equals. Okay? Now, this one we have to graph. All right, well that's not a problem. Okay, our anchor point is -2, -1. Okay, opposite the inside, follow the outside, so 1, 2, down 1. Okay, I'm going to go through. All right, x plus 2. Whoops. Draw. Okay. All right, G-solve, root. One of the roots is at -3, and if I hit over, it's -1. All right, so -3 at -1. Well, that's already helped me. Okay. All right, we'll finish this in a second. All right, then G solve max, don't have a max. G solve minimum, -2, -1, that confirms my anchor. G solve y-intercept, 0, 3. 1, 2, 3. Okay, so then my graph looks like this. Okay, as far as writing my answers, I got x equals -1, x equals -3. So you can see that. And that's sort of run out of room there. This will be y equals 3. I'm sorry, x equals -1, and x equals -3. And this answer of y-intercept would be y equals 3. Okay, so like I said, there's not a whole lot to that, all right, when it's graphed for us. Okay? Okay, now, as we get into increasing, decreasing, and the end behaviors, the big thing for this is to make sure you label your anchor points and your arrows. Okay? So the anchor point here is 1, 1, 2, 3, 4. So 1, -4. Okay? Now let's talk about how you label an arrow, because this is going to be very important. When you label an arrow, okay, if that arrow is to the right, you're going to use positive infinity. If that arrow is to the left, you use negative infinity. Okay? So when you look at the graph, left side would be over here, right side would be over there. Then the second coordinate, if the arrow is pointing up, it's positive infinity. If the arrow is pointing down, it's negative infinity. In later chapters, we'll get to when that arrow levels out, but we're not going to worry about that for right now. So for this one, this is a right arrow. This is a left arrow. Okay? So negative infinity, positive. Now this arrow is pointing up, so it's positive. So this arrow is pointing up, and it's positive. Okay? So, when we are doing increasing, decreasing, all we care about are these x coordinates. Okay? Alright? Now, for increasing, decreasing, okay? Alright? I'm going to show two representations. Okay? Regular notation and interval notation. Alright? So, for regular notation, okay, all right, what we do is we start from the left and we trace. If you feel like you're falling, that's a decrease. Okay, if you feel like your finger is going down, it's decrease. If your finger is going up, it's increase. So this is the decrease, and then this is increase. So when I fill in this stuff, the increase is from 1 to infinity. So the way you write that is 1 to infinity. Okay? All right, now, another way you could see that, all right, and the reason why we use these is that the change is not at a point. So you could see it written like this, 1, comma, infinity. It can be written either way. So this is like you can write them either way. It'd be fine, or see them either way. The decrease is from negative infinity to 1. So negative infinity to 1. You always put the x here, or you could write it as negative infinity to 1. Okay? Now the end behaviors, either or. So I would take either as an answer. Okay? End behaviors is x approaches infinity. So what I do is I find the x coordinate that's infinity, then I got to ask myself, what's the y coordinate? Well, that's also going to be positive infinity. As x approaches negative infinity, what's the y coordinate? The y coordinate is also positive infinity. Okay? So let's go ahead and graph 14. Okay? So hopefully we can see that graph. Yep, we're good. Okay? So what I want to do, all right, my anchor point here will be 5, 0. 1, 2, 3, 4, 5. Okay? All right? And now I'm going to go ahead and graph this. All right, we're going to draw. Okay, G solve root. All right, 5, 0. Check to see if there are any others. Nope, that's the only one. I've graphed that already. G solve max. All right, 5, 0. That's it. It's already graphed. G solve minimum. And don't have one. G solve y-intercept. 0, negative 25. So that's way down there. And if I look at my shape, it does something like this. All right. So what I got to do is label my anchor points. So that's 5, 0. All right, now this arrow is a left arrow, so that's negative infinity. Okay, but since that arrow now is pointing down, that's also going to be negative infinity. Okay, this arrow over here is a right arrow, so that's positive infinity, but it is going down, so it's negative infinity. Okay, hopefully you can see that. Fantastic, you can. Okay, now what I do is I start from the far left part of the graph. If I trace my finger, this is going up for increase. Then I hit this point, and now this is going down for decrease. Once again, when I'm doing increasing, decreasing, all I care about are these x coordinates. Okay? So once again, I'll show both representations. So for increasing, this would be from negative infinity to 5. Another way that it can be written is negative infinity, comma 5. Okay? Okay, either one is acceptable. The decrease is from 5 to infinity, or you can write it as 5, comma, infinity. Okay? As x approaches infinity, that would be here. The y is negative infinity. As x approaches negative infinity, the y would also be negative infinity. Okay? All right? Moving on. 15. You can go ahead and assume this is a dot, and you can assume that's an arrow. Okay? Now, doing domain and range, no different than doing the intervals. We want to label our anchors. Okay? That's going to be negative 2, 0. If you have a min-max, when we get the polynomials, you'll do that as well. This is a right arrow, and since it's going up, it is positive infinity. Okay? All right? All right, so, I'm going to write this in interval notation, okay, all right, to make it easier, all right. Domain, okay, domain means small x, big X. Let me write this a little bit better. Domain means small x and big X. Range means small y, big Y. Now, when you write these, if it's a closed dot where the point is, so like the smallest x value here is negative 2. Now, since that negative 2 is at a closed dot, we're going to go ahead and do a bracket. Okay? It's like a little square bracket. The infinities, the arrows are always positive, are always curved brackets. So that would be the domain. The smallest y value, okay, would be 0. And since it's there, it would be a bracket. And that would be infinity. Okay? So that would be the range. All right, that would be the range. Let's do this picture over here. Okay, so if I draw this, okay, label this. I know this is hard to see. That looks like 1, 2, 3, 4. 1, 2, 3. So we're gonna assume this is 4, negative 3. All right. If it's not that, if there's something else on the graph there, just run with that. This arrow would be positive, positive. This arrow, since it's left, would be negative, but it's also going up, so it would be positive as well. So domain. When I look at all these points, the smallest x value I see is negative infinity. The biggest x value that I see, not 4, we treat infinity. If you ever get confused with infinities, you can treat infinity like 100. And you can treat negative infinity like negative 100. If you need like a number, like to understand realistically what those are. So the idea would be negative infinity, that negative 100 is the smallest x value here. Positive 100 is the biggest x value. Now, what this basically means is that means all real numbers. Alright? But you can just write that. That is fine. The range, the smallest y value I see. Well, infinity is 100, that's negative 3. So since negative 3 comes at that point, it's going to have a bracket. The biggest one I see is infinity. Okay? Alright? Moving on to these other two. Okay? Alright? 0, negative 3, that means My anchor would be 0, -3, 1, 2, 3. Okay? Maybe I'm going to label that. We're doing domain and range. Okay? G-solve root, -1.7. See if there's any others, 1.7. Okay, so here. Here. All right? We'll check the other things. G-solve max. Nope. G-solve min. Already there. G-solve y-intercept. There. Okay, graph looks like this. All right, this would be infinity. Infinity, because it's going up. This would be negative infinity, infinity. Left arrow, right arrow, both up. Okay, so the domain, if I look at all these, the smallest x value I have is negative infinity. The biggest x value I have is positive infinity. When I look at the range is the y's. So infinity, -3, infinity. Well, the smallest one there is -3, the biggest is infinity. Okay? Anchor point here would be -4, -3. All right? 1, 2, 3, 4. 1, 2, 3. Okay? I'm going to label that because I'm doing domain and range. Okay? So now I'm going to go ahead and graph that. All right, x plus 4, oops, -3. Okay. All right, now I do G-solve root, don't have any. G-solve max, -4, -3, fantastic. G-solve min, don't have one. G-solve y-intercept, 0, -7. 1, 2, 3, 4, 5, 6, 7. All right, so here. All right, here, all right. So that would be positive infinity. It's a right arrow, but it's going down. This is negative infinity, it's a left arrow, and it's also going down. So when I look at the domain, smallest x value that I see of these three is going to be negative infinity. The biggest x value that I see will be positive infinity. Once again, that would mean all real numbers. Okay? The smallest y value I see is negative infinity, and the biggest y value I see is actually -3. And since that -3 is at a close point, fill in that. Okay? 19. Okay? Circle all of the following that have a range of -2 to infinity. Okay? So what I'm going to do to help do that is I'm going to go ahead and make a rough sketch. All right? So I'm going to go ahead and go option num abs x with a -2 on the outside. Whoops, that is not correct. All right, and I'm not going to worry about overly graphing this. I'm just going to look at, all right, my anchor is 0, -2. All right, so it looks like that. I'm going to do G-solve root, okay, -2, 0. All right, G-solve max, no. All right, G-solve min, okay, 0, -2. All right, G-solve y-intercept. Okay, so what you have here is 0, -2. Okay, and this would be positive. This would be negative positive. Okay, so all I want is range. So range is y. So my smallest y value of everything I see here is -2. My biggest is infinity. So that would be 1. Okay? All right? If I go to the second one, right, square root, x plus 2, draw. Okay? All right? So I know my anchor point is going to be here at -2, 0. So really all you care about are the anchor points. Okay, and that arrow would be positive, positive. Once again, all right, I am looking for my y values. Okay, so my smallest y value I have is 0. The So that's a bracket, the biggest one's infinity. So that is not what I'm looking for, okay? Now let's go ahead and look at this one. That anchor point would be negative 2, 0. All right? Just so I get the picture. Okay, looks like that. All right? So this is going to be negative 2, 0. This would be infinity, infinity. This would be negative, positive. So my smallest y value that I have is 0 again. And my biggest is infinity. Once again, that's not what I'm looking for. Okay? 0, negative, or this would be x squared minus 2. So I'd have that. Okay? Would be my anchor point. Okay, so that's my anchor. This would be positive, positive, negative, positive. All right, my smallest y value here is negative 2. My biggest is infinity. And since that negative 2 is at a point, so that's another one that I'm looking for. So as you can see, the anchor points are really telling how that's going to go. Now this one's a line. So we say, Mr. Evans, I don't know how to do that one. Well, let's look at this. Okay? X plus 2. All right? Let's say you said, I want to apply that same principle, but my anchor point is at 0, 2. Well, if you look at this, my line, that would be positive infinity, positive, because the right arrow going up. This would be negative infinity, left arrow going down. Okay? So the smallest y value you have is negative infinity, and the biggest is positive. So in that case, that is not one of the ones you circle. Okay? Using words to describe the transformation. All right? You could give me a shift left 2, because my anchor point would be negative 2, 0. And then we talked about this would be a dilation of 3. Okay? This one